So the difference quotient, for now, I'm just going to do it as like a 3-step process. Remember, we did our f of x plus h, then we did f of x plus h minus f of x, and then we divided that answer by h. Here my function is g, so it's g of x plus h. Not that that really matters, just the name of the function. So that just means you replace your x with x plus h. Is there anything I can do after that? No. Okay, so that's it. So then we have to take that answer and subtract the original function. So negative 3 over x plus h, and we subtract the original negative 3 over x. So first of all, if we have minus and negative, we switch our signs, so it's plus positive. If you want to add fractions, what do they have to have? Common denominator. Why is it annoying? So this first one, what would you have to multiply by on top and bottom? And this one's going to get multiplied by? Over, we could multiply out the bottom. I'm just going to leave it as x times x plus h. Plus 3x plus 3h over x times x plus h. Now the denominators are the same, so we put them together. When we do that, the bottom doesn't change, just the numerator. Positive and negative 3x would drop. So we just have 3h over x times x plus h. Questions there? So then the final step is to take the answer we just got and divide that whole thing by h. This is like h over 1. How do you divide fractions? When we do that, what happens? So we just get 3 over x times x plus h. So we had to refresh our common denominator skills. Questions on these? Do you need more of any of these types? We're okay with that? Okay. Let's refresh some piecewise stuff. So here is my function. It's a function, so I know that if I plug in a number, I can only get one answer out. So I can't put negative 2 into both of these. I'll get 2 answers. Which one do we use?
The top.
You have to look at the rule. Is negative 2 less than or equal to negative 1, or is negative 2 greater than negative 1? It's less than, so we use the top. So that's 1 minus the negative 2. Alright, you guys do f of negative 1 and f of 0 for me. Which one did you plug -1 into? Top one, so 1 minus -1 gives you 2. And 0 goes into the bottom, so 0 squared is. Alright, we good with those? Do you remember how to draw the graph? Graphs can be helpful.
The,
The negative 2 is y.
Mm-hmm.
And is it-
Well, sorry. The,
Or wait.
yeah,
that
this
balance?
is your x.
Yeah.
And
Okay.
that's your y. Okay, so I have 3 points. Is that enough for my graph? What did we do?
get one that's greater than one or negative one.
Yeah, do you remember, in general with these, we did T-charts, and we would do a T-chart for each piece, so that we figured out what it looked like. So since this one's 2 pieces, you would have to have 2 T-charts. So if I'm talking about the first piece, what's the first x value you have to put in there? The -1, and we already know when we put that in, we get out 2. And then you need things less than -1. So if we put in -2, we got 3. If I wanted to do one more, if I put in -3, what would we get out? Okay. So then, when you graph those, remember you also had to watch open and close circles? How did you know if it was open or closed?
Greater than.
Yeah, that equal to means closed. If it doesn't have an equal to, it's open. But that's just the first point. So -1, 2 is a closed circle. And then everything else is as well. So -2, 3, -3, 4. So it started here. We continued for everything less. Again, I know I'm going to the left only because it started at -1 and the x's were smaller than that. Then we have to get the other piece. And what x do we have to plug in first there? Mhm. We actually still have to do the -1 because, yes, 0 is the first integer bigger, but you could do like -0.9, -0.99. So we had to do the -1, but because it didn't have an equal to, we made ourselves a note that would have to be an open circle when we graphed it. And then we need things greater than -1, so maybe 0 and 1. So if I put those in, -1 squared is 1, 0 squared 0, 1 squared 1. So -1, 1 is open. 0, 0, 1, 1. If you weren't sure, you could always do more. If you put in like a 2, you get out 4. So we're getting part of a parabola. Start at my open circle, continuing to the right. And we know it's a function, so how can you quickly look at your graph at the end and make sure it's a function? What do you check for? Vertical line test. So make sure that will catch if you accidentally had like 2 closed circles in one spot. Alright. Questions there on our piecewise function? The last thing that I want to talk about with functions is domain. What is domain? What's that refer to?
Left to right.
When you're going from left to right on the graph, it's your possible x values. What x's can we plug into this function? So if we're looking at a graph, we just went from left to right and we gave an interval. If you don't have a graph, we had to look at the function itself to identify the domain. So what were the rules that we had to worry about? One issue we saw was when we had fractions. What's true in a fraction?
Denominator can't be 0.
Yes. If you're looking at a fraction, the denominator or the bottom of that fraction can't be 0. So even if we didn't have the graph, we could just look at that fraction and say, oh, that's gonna make the bottom 0. So if I had like x over x minus 2, then I know x can't be 2 because that would make the bottom 0. So my domain is everything but 2. Remember, we'd write that as like negative infinity to 2, and 2 to infinity. Everything smaller than 2 and everything bigger than 2. What about with radicals? What do we have to remember there? So I said like the square root of x minus 4. Can you plug any possible x values in there? That x minus 4 has to be greater than or equal to 0. Okay, so my x had to be greater than or equal to 4. Which meant my domain was everything from 4 to infinity. So if you have a radicals, the radicand, so that's the thing under the radical, is greater than or equal to 0 in even radicals. Remember, if it's a cube root, you can have anything underneath there. So if the index, that little number outside the radical, is odd, it's everything. But if it's even, it's greater than or equal to 0 because we don't want to get imaginary numbers. And the last thing that we need to touch on would be logs. So if I said natural log of 3x minus 1, what did we have to remember there? Well, that was a long time ago, wasn't it? All right, let's have a little detour. Let's do a quick log refresh. We'll talk about them more later in this chapter, but just basic. If I say like log base 2 of x equals 8.
Don't be an asymptote.
Mm-hmm. So how do you write that as an exponential? 2. Okay, remember in a log, this base had to be a positive number. If you take a positive number to a power, what kind of answer do you get? Positive. So in a log, the argument, the thing in the parentheses, is always greater than 0. Not equal to, just greater than. So in this case, the 3x minus 1 is greater than 0. So x has to be greater than 1/3. So our domain would be 1/3 to infinity. All right, so those were the 3 issues that we encountered. If it's a fraction, the bottom can be 0. Even radical, your index has to be greater than or equal to 0, and logs, the argument is positive. All right. I'm going to give you guys a few minutes. Do as many of these as you can. So first one, it's a square root. So the argument greater than or equal to 0, so x has to be greater than or equal to -2. We prefer interval notation, so that's everything from -2 to infinity. Does that make sense? B, it's a fraction, so all we care about is the denominator. So x squared minus x can't be 0. I would factor that, so you could take out an x, so x times x minus 1 can't be 0. So what can x not be? Last year I did let you, remember if there were multiple values it couldn't be, I did let you leave it like that. We could also do the interval. It's everything except those, so it'd be everything smaller than 0, everything between 0 and 1, everything bigger than 1. So I would take either of those there. So in those fractions, factor your denominators, that way you can check if there's multiple things that make it 0. C, do we have a fraction? No. Do we have a radical? Do we have a log? So what's our domain? Doesn't break any of our rules, it can be any. Alright, D, we have a few things going on. We have a fraction, so if I look at that fraction, I know the bottom, so x can't be 0. I also have a radical. Do I need to worry about that radical? Why not? My index is odd, so I don't have to worry about it. So it's just x can't be 0. So negative infinity to 0, union 0 to infinity. Alright, E, what do we have to do? The bottom can't be 0, so that would factor into x plus 3, x plus 4. So x can't be, if I did, how would I write that interval?
Negative infinity to -4, union -4, -3, union -3.
And F, we have a log, so we know in a log the argument, so 2x plus 5 is just greater than 0. So 2x is greater than -5, so x is greater than -5/2. So that would be parenthesis because it's not equal to -5/2 to infinity. Just as a reminder, when you're solving those, if that had been like a -2x and you had to divide by a negative, what happens to your inequality? It flips. Okay, good. Any questions about domains or piecewise functions or difference quotient? So we do have quite a bit of time. I want you to finish that worksheet. I'm hoping we can grade it before the end of the hour. So